Awesome. Okay, so let's get started. Is anyone else having linker errors when they're trying to compile um, essentially the Novocaine audio? So just you guys. And
I had the same issue where occasionally people don't tell where if you do it right after.
We've been doing that for like 45 minutes, and it's not the case.
no, I don't know. I don't know what's going on. I don't know.
We had a problem like that, but we didn't.
No, the project we posted
is working now. So.
Which framework were you missing? Just the GL kit?
I had that created that error too, but I fixed that.
Yeah, I'm on. There's a framework somewhere. I don't know why that framework is not auto getting detected. Everybody else is having it auto detected except for this project in particular, right? Or something to do with these view controllers. So, huh? Is that a problem? Is that?
It is a problem.
Oh, yeah. That's a great question. We'll debug after lecture. Are you guys going to be around for lab?
Yeah.
Okay. Okay. So, welcome to Lecture 9, Mobile Sensing, Learning, and Control. Today, course logistics. So, A2 is due Friday. I think everyone knows that. So, essentially, the updates for Module A, just so everyone knows, you only need to detect 2 tones that are 100 hertz apart and 12 hertz accuracy plus or minus 6 hertz. Right? So, for Module A, that's good. A3 is due the following Friday. It's essentially it's a 1 week assignment, and I'm thinking about extending it a little bit to give you guys a break from the audio lab. So what I'm thinking is instead of Friday, making it that following Monday, so you have 2 weekends that come in there. This is a much more drummed down project, right? That's why I made it 1 week in the first place. But essentially, I'm thinking about making it due after lecture. Basically a week from Monday. A week from this coming Monday. Yeah? I don't think anyone's going to fight me on that, but yeah. Okay. So I will go over the specifics of that. I mean, it's up on the website. I'll go over the specifics of it next time. It is not going to be as intensive as the audio lab, which is why it's a 1 week lab. So for the agenda today, I want to talk about things that are going to be related to assignment 3, which is specifically getting the activity of the user, how to use that, doing step counting, working with persistence with small data, so essentially using NS user defaults. And then I'm going to talk a little bit about accelerometers, gyros, and magnetometers, and if we get to it, graphing feedback to the users. Okay, so we'll see what we get through today, and I'm going to try and make these extended demos, and the demos kind of, as long as they go and people are asking questions, the demo continues. Okay? We'll see what we get through. Okay, so last time we got cut off, but essentially we were talking about activity from the M7 coprocessor. We were talking about using the core motion framework. And when we're wanting to grab activity, all of this is mediated through a class called ActivityManager, where we can ask it, is our device capable of even inferring activity? And we can query the past activities and subscribe to any changes in the activities that occur. And we talked about interaction being completely based on blocks of code and the handlers. So essentially what we had here is this code. When we want to subscribe to the notifications that are in a code, first thing we do is import the core motion framework, declare an activity manager. So this is just our CM motion activity manager. I'm making it a property here of the class. And what's that going to allow us to do is ask if the device is capable of inferring activity. So we use this function, is activity available? If that equals yes, I'm going to go ahead and say, okay, self.motionActivityManager, right, which is my motion activity manager here, and I'm going to allocate and initialize that CM motion activity manager, which means it's ready now to infer activities or go and query activities, right? So now I have an instance of that class. The next thing that I do here is essentially I'm going to check again to see if activity is available. And then I'm going to go in here and use this instance of the class, self.motionActivityManager, and I'm going to call this function start activity updates to queue. All right, so I'm going to subscribe here. And the queue that I'm going to run on for the activities is the main queue, right? So what does that mean? Yeah. Yeah, it's the same thing that the UI is running on. The user interface is running on the main queue, right? So essentially, all of these blocks that I add in here that have access to this variable activity, they're going to be running on the main queue, right? And if I'm adding a bunch of blocks to the main queue, that's bad because it might interrupt user interaction, right? So if I do something inside of this block that is really, really processor intensive, it's going to look like it's blocking to the user. It could halt animations that are happening on the phone. Okay? So I'm going to want to do something here and get out quick. Yes?
Can you not just change that from main queue to a different queue that you have set up?
Absolutely, you can do that to a different queue. The only reason that you might do this on the main queue, the only reason that I wouldn't count you off for doing this on the main queue is because the start activity updates to queue. An update to the queue, basically you'll get this will get added to the main queue maybe once a second, probably once every minute. It's getting like anything that gets added to the queue here, like you're going to deal with the activity, maybe save it to a database and then move on. Right?
So that this only gives you the high level information that you were talking about.
This only gives you the high level information, and I'll go into that next slide.
Something else is for the raw data screen.
Yes. All right, so this is the block where I'm going to handle all of the updates. You'll notice that the update in here, this is a block that I say, okay, so start activity updates to the main queue with handler, and then here's my block. What's the variable that this block gets access to? Activity. Bam. It's like a function, right? So whatever I put in here is going to have access to this CM motion activity class instance that's passed in. Okay? And whenever I'm done, I end subscription, right? So maybe in my dalloc, or if I've decided I'm not going to listen into the activity of the user anymore, I will call this class, basically this instance method, stop activity updates, and that will stop sending this block to the queue when an activity occurs. Okay? Good. Okay, so what is inside of an update? So here's the update that I'm talking about right here, the update to queue. And essentially, we are updated when any part of the activity estimate changes, right? So whenever I go from still to moving, or whenever I get in a car and it detects that I'm in a car. And what I'm going to get back is essentially this CM motion activity class with the following fields. Right? So we talked about this last time where I could tell if the user was walking, whether they were stationary, running, automotive, unknown. So it will tell you if it has no idea what the activity is going on right now. And it'll give you a confidence estimate, right? Which tells you how confident it is that the user is still. So inside the handler, you have access to the CM Motion Activity Manager. And if you want to get access to any of those things, it's as simple as accessing the fields of that activity class. So activity.confidence, that's going to be an enum down here where it's a CM motion activity confidence low, medium, or high. All right? So what I'm doing here is I've got some confidence label that I'm just changing the text to when the confidence changes, right? And then this right here, I'm spinning out an NS log of everything that's in there. Okay? That is pretty simple if you want to get the user's activity. Right? You're not doing any inference except querying the M7 processor. Right? Okay. If you want to go in and query the different activities that have happened in the past up to 7 days, you can do that. And you'll be querying the M7 coprocessor for all of that information. So the way that you do that is the first thing you do is you set up a date range in which you are looking for the activities that the user had that are saved on the phone, right? This is whether or not your app was running or not. The activities are being inferred and saved to the phone. So even before your app is installed, you have 7 days of information as long as they've had the phone for 7 days. So what I do is I'm going to create a date. So here's ns date. This is the current date right now. And then I'm going to do this from variable where I say ns date with interval. And then I say negative 60 times 60 times 24. How long is that?
7 days.
Is it? 1 day, right? So this is the time interval in seconds, right? So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, right? So here's my now and from. And now when I go into my self.motion activity manager, instead of start updates to queue, I'm going to say query activity starting from date from now. I'm still going to give it a queue to be able to put all of these blocks on, okay? And this is where you might not want to put this on the main queue. Because if the user had, everything that they've done for the past 7 days, potentially they're changing their activity every 10 seconds or something. This could be a lot of data that comes back. All right, so maybe you want to put in a queue here that you've created on your own. But essentially what I'm going to do here is what you're going to get back is, here's the output that you get. So this handler has an input array. It's an NS array of activities and an error. Okay? So if you want access to these activities, then essentially what I'm doing here is for each CM activity inside of this activities array, I'm just spitting out whether or not the user was walking with this start date. Question?
Is the size of activities just the number of seconds? So it doesn't spit out one activity per second, right? It's variable.
No. It's variable. The size of activities is the number of activities.
Okay.
Like it's a variable number,
So
right?
you index for time. In other words, like when it happened.
Yeah. So that's why you have this dot start date.
Oh, okay.
So each of these CM motion activities has a start date, and all of those, like these are all activities that you would get like if you were actively subscribed to the queue. Right, it's going to give you here's the start date, here's whether they were walking, running, in the car, right? So you're going to be able to tell exactly how long someone was in a car based on 2 separate activities, right? And you look at the difference between their start dates. And this is all information that your apps have access to, by the way. This is information you're giving up, just in case you didn't know. One thing that I'm not doing here that you probably need to do is handle this error. If for any reason you give it a date that is before 7 days, it's going to give you an error, right? And so activities might be empty. So you'll want to check this error to make sure that you're getting something back, right? If error equals nil, you're fine. Otherwise, probably need to adjust your dates that you give it. Okay?
What does CM activity done walking return?
That is a 0 or a 1. 0 if they were walking with this timestamp, and 1 if they weren't. Right, so essentially, this may have been they went from still to in the car, right? And so walking might stay 0 over multiple frames, right? But essentially, all of these different activities, you get a new activity when it changes. So you have a variable number. All right, pretty simple stuff. You can also do more than activity. The M7 processor is tracking the number of steps during each of the activities that are there. And you can get updated by the OS when you want to do step tracking, step counting, and it's extremely similar to that CM Motion Activity Manager. So if you want to do step counting, there's a special handler from the M7. So what you're going to use is the CM Step Counter class, and its updates are really, really similar to the Activity Manager. So what I'll do here is I'll declare this property, which is a CM Step Counter, right? So CM Step Counter, a pointer to it. And then I'm going to call this class method CM Step Counter is step counting available, right? Because if I'm on the iPhone 5, this is going to be a no. If I'm on the 5S, it'll be a yes. And essentially, I'm going to allocate and init my CM Step Counter with the class methods, right? The next thing I'm going to do is I'm going to say self.cm step counter, start step counting updates to queue. Right? So whenever I call this, it's gonna zero out the steps, and it's gonna tell me how many steps I've had since I've called this method right here, start updating to queue. So I give it a queue that I want to run on. In this case, I'm running on the main queue, And I'm not going to dock you for running a step counter on the main queue. And the reason for that is because the OS decides when you get an update. Right? So what this method does is start step counting updates to queue, the main queue. Update on, this is your update interval. How many steps do you want before your code gets called? And this is your preferred estimate. Okay, so I'm saying here, I would like to get an update from the code every time the user takes a step. Okay, as fast as you can give it to me. Inside of this handler, what you're going to get is an NS integer of the number of steps that have been taken since you called start step counting updates. Okay, so the first time you get an update, it might be 4. You've taken 4 steps. The next time you get an update, it might be 12. Right, so the user's taken a total of 12 steps since you called start step counting to update to queue. Okay? So you get the steps since you subscribed, you're going to get the step count and when it was valid, right? So you'll get a timestamp for when that number of steps was actually valid. And when you're done, you're going to clean up, CM step counter, stop step counting updates. Pretty simple, right? Very, very similar to the Activity Manager. All right? Do not rely on that update. Even though I told it I wanted to be updated on every single step, that is not going to be reliable. First of all, it's not going to give you an update for every single step of the user, okay? It won't do it. It might give you every 4 steps, every 5 steps, but it's not going to give you what you asked for. And if you see that it keeps giving you steps every 4 steps, don't expect that to happen all of the time. It's very unreliable, right? So even though you're setting this preferred interval, that's not going to happen, right? iOS determines when you get that update. All right? If you're upset about that, don't be. Because that optimizes the battery life of the phone. Okay? It makes sure that anytime you're querying for this, it's not at the expense of interaction. It's running stuff on the main queue, and step counting has a lower priority. It minimizes bus traffic on the chip, so when it's actually communicating with the M7 processor, it wants to do that in batches. Right? It doesn't want to just continually query that. And even if your app gets turned off or shut down, it's still keeping tracks of steps in the background. It's always doing step counting. Always. So you can always query it for, oh, my app, it crashed or the user got rid of me. What were the steps the user took in this period of time? You can always go back and query that. And that's also saved by the M7 coprocessor. So you get background updates for free. So if you want to query past steps, extremely similar to the Activity Manager, essentially you'll set up this date interval, right? So I want the number of steps that happened in a 24-hour period from now to 24 hours ago. Query step counting from to now. I'm going to do this on the main queue. And that's okay to do this on the main queue because this gets called once and then it returns. All right, so essentially what happens here is you're going to get this number of steps, and that's it. And you'll get an error, right? So essentially I could say, well, here's the number of steps from to now. And that's what this is. All right? Pretty cool stuff. Step counting didn't used to be this easy. All right, handle the error as well, just to make sure, because if you give this dates, again, that it doesn't have dates for, it'll give you an error and tell you what that error is. It's like, hey, I didn't have this for before February 14th or whatever. Okay, storing persistent data. So we're going to do a really quick aside now that we have activity and now that we have step counting. And I want to talk about this thing called NS user defaults. So there was some questions at the beginning of the semester really on if I want to save the state of something that I have in an application, and I don't want to use core data, or I don't want to save this, keep updating a file that's local inside of my application. Well, NS user defaults is a way to store primitives and encapsulated data, really encapsulated data, right? So the way that this works is NS user defaults is not specific to your app. It is specific to the phone. So essentially what you're doing is you can store key value pairs. You can store a dictionary of different primitives that you want to be saved persistently. So I can say NS user defaults, standard user defaults, and then I can get a handle to that class, the standard user defaults. What that allows me to do is call things like set integer for key primitive integer, right? So this would be, I wanted to save the number 252 because the user had set that for something in my application. All right? And if primitive integer doesn't already exist in NS user defaults, it's going to create that and store it persistently. Okay? And I can do that, so I can set an integer, a double, a float. I can also, let me see if I got some. Yeah, and so these are going to be nil if they're not defined. I can also save generic objects, right? So not just these primitives like integers and doubles, but also, you know, instances of a class. So objects that you can store into NS user defaults have to be of this type. They have to be either NS data, NS string, NS number, NS date. They could be an NS array or an NS dictionary. Okay? Question?
Could they be an NS array of other objects?
No. So these are objects. So they can be an NS array or an NS dictionary, but they have to be what's considered a property list. A property list is like an NS array or NS dictionary that has nothing but these objects in it. Okay? So you can have an NS array of NS dates, or you can have an NS array of strings, numbers, and, you know, all mixed together, right? But it has to be what's considered a property list. It has to be something that the OS knows how to serialize locally so that it can store it into the persistent data. Okay? Is that okay? Question?
Do you have a memory limitation for the user defaults?
You don't put a whole lot of data into NS user defaults. Just like store a couple of things for your application. Don't start sampling like features and store it into NS user defaults. It's going to be terribly inefficient, right? That's where you use core data. You use your own database. But you've got a couple of things that you want, you know, to live inside of an application space. And this could be between applications. Like, let's say you're manufacturing a bunch of different applications. If you set this NS user default key, you've got another application that can get access to that number too.
Like a username?
Yeah. Yeah, exactly. Okay? The last thing you'll want to do is save any changes that you made to the standard user default. So even though I've called this function, you know, set primitive integer, that key equal to 252, that is not saved in the user's defaults until I call synchronize. Okay? And that's when it actually goes out and serializes it and makes sure that it's persistently stored. Okay? Puts it in Flash. Questions? Okay. So I went over setting. I didn't get over getting from NS user defaults. It's really, really simple. When would you use NS user defaults?
For the settings of an app?
For the settings of an app? Sure. Yeah, absolutely. Let's say you're doing assignment 3 and you want a step counting goal. You want a user-defined goal for the number of steps they want to take in a day. You don't want to set that every time you have to launch your application. So maybe you do something like this, where I have this variable called daily steps goal, and it's an NS number equal to 50. I open up NS user defaults, standard user defaults, and I say, okay, I'm going to have an NS integer, and I'm going to get integer for key from standard user defaults, daily step goal. Okay? And that's going to return a value right here. If this key did not exist, this is nil. Doesn't exist. It's going to be nil. It's not going to throw an error. It's going to return nil. So if daily step goal from user doesn't exist, right, then instead of calling integer for key, I'm going to go ahead and set that integer to what I have my daily steps goal to be right now. Right? So if not, set it, synchronize, and return. This would be a really good method to have in, say, a getter. Right? Lazy instantiation, call NS user defaults only if you need to. Yeah? Any questions on that? Let's do a demo. All right. So Huh, yeah. I was using core image for that. Let's actually just create a new project. I'm going to do a single view application. This is going to be an activity at step counting demo, so I'm going to call this motion demo SMU. The class prefix that I'm going to have here is, I don't know, what should I do? Motion? Sure. Okay. So we'll create it. Let me go into preferences here, make this bigger so that people can actually see it on the screen here. Okay. So essentially, here in my motion view controller, what I'm going to do is, I think I'm just going to lay down a slider. Okay? And I'm going to update that slider for step count. Okay? So let's count steps first. So what's the first thing I would need to do if I wanted to do that? Grab a slider in. Whoa, what just happened here? No. All right, so now I've got this slider right here. And let's say I want this to be a percentage of my step goal, right? So essentially what I can do here is, what's the first thing I do when I lay something on the storyboard?
You do constraints.
I'm going to do some auto lift. So top space, I'm going to set that here. Everything's orange, which means I haven't set this up all the way, right? Let's just have it take the entire length here. Okay? And I'm going to set up some constraints on this. Yeah, give me 20 and 20 on each side, and give me a constant height, because it's a slider. Right? At these three constraints, hey, everything turned blue, I'm good to go. All right? So the next thing that we need to do is create an outlet for this, right? All right, so pretty simple here. We'll just create an outlet for this slider. And we'll say, yeah, we'll call it step count slider connect. All right. Very happy with ourselves. So let's go over here to motion view controller. And what's the first thing we want to do? We want to basically instantiate a CM step counter, right? So let's do an at property. We'll do strong. Wait, do I need to do strong here? We do. If I don't do strong right here, I'm going to allocate this. I'm going to be the only one with a weak pointer to it, and it's just going to go away immediately. It'll be immediately set to nil, right? Because no one else has a strong pointer. Okay. So the first thing I'm going to do is let's import core motion. So it's all right. So we import core motion, and now I'm going to call the CM step counter right here, and I'm just going to call this CM step counter. Okay. Good. So now we have a step counter. What do I need to do now for my CM step counter?
Query the M7.
Well, I need to instantiate it first. But yeah, eventually I need to do that. So let's instantiate it. If I want to instantiate it, how should I do that such that I'm using Objective-C principles?
ActivityManager.
Yes, but if I want to instantiate it, should I do it inside viewDidLoad? Getter. I should use lazy instantiation. So in the getter for this, what I'm going to do is essentially this is going to return a CM step counter, right? And it's going to be called CM step counter. It's already ready for that. Okay, so the backing variable for CM step counter is underscore CM step counter, right? So if it doesn't exist, if not underscore CM step counter, and then at the very end I want to return it. Well, the first thing I want to do before I allocate and init this is check to make sure that the device is capable, right? So if I can call a class method CM step counter is step counting available? Look at that. You should always, if you're going to do, by the way, if you're making a class method on your own, if the user is asking someone or you're expecting people to use your public API and query some information whether or not they can do something, start that method with is, right? Because it reads a lot better than this. Is that okay? Is step counting available, right? They could have called this step counting available. I don't know. I would have had to go into the documentation to really figure out what that function does. Okay, so if step counting is available, then underscore cm step counter equals what? Alec and it? Good? Right? Otherwise, it's going to be nil. And I can send messages to nil. It's not going to do anything. Okay, so now down here inside the view did load, this is when I want to subscribe to those updates, right? So essentially what I'm going to do here, we're going to go self.cm step counter. When I call self.cm step counter, this getter gets called, it gets instantiated, right? So I can call that start step counting updates to queue. I'm going to double click on this so it kind of autofills the function in for me. I'm going to go ahead and run this on the main queue. Whoops. So I'm going to call ns operation queue main queue. All right. Update on. We'll try for every step. We'll try and get every single step that the user uses. Okay. And I'm going to have it autofill in this handler. And then I'm going to end the method. Okay, so let me tab over.
How do you do that? The upfill?
Autofill? I just double clicked it.
No, thank
Or you can also, I think tab works as well. Okay, so here's my handler. Let's move this over so that it's actually something. Okay. Whoa, a little too far. Okay, so what do I want to do? Well, I also want to have some user goal, right? Yeah, so at property, we're going to do a strong, non-atomic, come on. And I'm going to have this be an NS number. And will be, this is the daily step goal. Okay? Now, in your project, I want you guys to go ahead and use the NS user defaults because it's a demo and I want to go quick. All I'm going to do is write a quick lazy instantiation for this. Right? So essentially, the daily step goal is going to be an NS number. Whoops. And daily step goal, if not underscore daily step goal. Is this blowing anyone's mind, or were we good? Okay, good. Underscore daily step goal. If it doesn't exist, then I want underscore daily step goal to equal an NS number. What number should our goal be?
100,000.
100 steps. Excellent. I heard 100 first. 100,000. I'm not doing 100,000. You won't even see the slider move.
Regular.
For the demo, I'm going to do 100 steps. Oh my god. This is when everybody gets active and starts asking questions.
You need to change your slider to a given value of 0 and 1. And then that 0 and 1.
No, it won't be. What do I need to do?
Slider value will probably max at 100.
So self dot, what did we call this slider? Step count slider?
Yeah.
So we call step count slider dot maximum value equals what? Equals 100. Equals self dot daily step goal. That's what it equals. Right? Is that going to give me an error? Right, it's an NS number, it's encapsulated. If I want to get a float value from it, I'm going to go ahead and grab the float value. I could just assume to get an integer from it. Right, so that's my daily step goal. And yeah, Okay, so now inside of here, what should I do? I got the number of steps, I got a timestamp, I got an error.
Update the slider with the number of steps.
Update the slider with the number of steps. If error equals nil. So if not error, do this. Now, if I'm not running on the main queue, what do I need to do here? I'm updating a slider inside of this queue. If I am not on the main queue and I try to update the UI, that is not thread safe. Okay? So I would want to call perform selector on main queue or perform on main queue using the C functions, right? To get under the UI. Okay, so if not error, then we want self dot, I already forgot the name of it. Slider.
Step count slider.
Yeah, see, I probably should have called this slider for step count. Anyway, so we'll call it step count slider. Dot value equals what?
Number of steps.
Number of steps. So this is going to give me the number of steps since I called start step counting updates to queue. Okay? And hopefully it's going to take that and put it straight onto our device. Okay? Am I missing anything? I don't think I'm missing anything. Value. It's a float value. Number of steps. View controller. It's an NS integer. It's an NS integer. It's going to auto cast that.
Wait, so why didn't auto that one and not the
Because NS is the next step. It's really not a primitive. It's encapsulated. It's an encapsulated integer. It's calling other methods in the background. All right. It's just verifying. It's like, oh, what's the return value? Oh, then I'll cast it as that. If it can't figure it out, it'll give you a warning. It won't give you an error. It'll give you a warning. Okay? So let's play this on my phone. Okay. Motion Demo SMU would like to access your motion activity data. If I don't allow, every time I try and access something, it is going to give me an error. Okay?
It doesn't ask you again.
It is not going to ask you again. If the user says don't allow, the only way to turn this back on is to go into side of settings for your application and be able to turn it back on. Okay? All right. Now I have to take steps.
You just take it down. No? Is that not?
Maybe it's just marked for that.
Maybe just
Oh, there you go.
Oh, here we go.
Now run. No.
I can run around. Hey, it's counting the number of steps. Okay? Yeah, you can fake it out. All right? It's doing this off of the motion data on the phone. All right? I've almost hit my daily goal. Look at that. Did you see that giant jump? That was like, I don't know, 24, something like that. No, oh, and then I got a step count when I took 5 steps. This is pretty good. It's not 100% accurate. Okay? It's about as good as a Fitbit, in my experience. Do you guys know what a Fitbit is? You do? Hey, look. Did you say your grandma has one? I have one too.
It was her Christmas present this year was a Fitbit. She has it tied to her iPad and her iPhone. And she tracks all.
Your grandmother?
She goes.
That's
to a
awesome.
Trainer every day. She's 78 years
So-
old.
Okay, that's actually, I'm really impressed here. So what? One of the things that I also wanted to do here is let's create a label and update that label. Okay, so that I'm not just relying on the slider to get what these values are. Right? So let's go ahead and get a label in here.
One question.
Yeah.
Is the slider still interactive? Can you like just move it with your finger even though it's...
It is. That slider is absolutely interactive. You know what? We should really make that not interactive.
No, that's it.
Good? You guys are spot on today. Okay. Yeah. All right. The label. Okay, so this is going to be, let's call this steps. Okay? I'm going to center it here. Let's just have it take up the entire thing. Okay. What happens if I go in here and sell it just like suggested constraints? What does it do? Left, left, flush. Up with that. It's pretty good. I think it's not bad. Your guys' thoughts? Pretty good? All right, fair enough. Keeping on moving. What's the next thing I need to do? Create an action. Why do I want to create an action on a label? Yeah, but I was trying to get I want to create an outlet, right? Oh no, I can't get the other. All right, so what should we call this? We should call this label for steps. All right, connect. This is weak, non-atomic. Why is it okay that this is weak?
Because you only when you're in the user interface.
The view has a strong pointer to it. And I want the view to manage when ARC comes and deallocates that from the heap. All right, so here we are. Label for steps. I'm just going to go down here and I'm going to set the text for that label. So I'm going to have self dot label for steps dot text is equal to in a string with format. Oh, come on. String with format, and then I'm going to create an ns string right here. It's going to be steps capital %d. Will that work?
No, because it's a float.
That's ns integer. Oh, it wants me to do a long. Okay, there. Cast it as a long and then set it in. Sure, why not? It's fine. Okay, so now the number of steps will be there. And yeah, we can go ahead and run this. Let's just make sure that it's going. Any minute now. Oh, it's going to be awesome. Whoa, did you see that? The first thing I got was 0. It took a little time doing this. So I got 6, 12, 18, right? Oh, hey, look at that. 24? Oh. Do not count on this to be reliable. All right, now I'm going to change my pace a little bit. I'm going to start walking this way. Or maybe this way. I'm already hitting my daily goal here. This is great. I'm running around. Okay. This is why everyone wanted me to make it 1,000. Okay, now, can I grab that? Nope. Oh, wait. I cannot. I'm trying to interact with it right now.
You just be lying to yourself anyways.
78. Okay. I like your style. That's good. Okay, keep coming back to that. Let's do an activity manager. All right? Let's say we want an activity to be displayed to the screen. I want to know whether or not I am running. Okay? So let's do that. At property strong non-atomic. What do I need? I need a CM. I need a CM activity manager. I need a CM motion activity manager. What the? Oh, it is there. Just kidding. CM motion activity manager. Let's call it CM manager. Okay? Core motion, CM. All right? Okay, what's the next thing I'm going to do? See, that's what I want. When I'm doing lazy instantiation, I want everyone to be bored. All right? I like the humor. I like it. All right. So, if not CM manager
You forget the nut.
If, oh, man, that would have been bad. Then I want to return it, underscores manager. And if it's not there, we want to say if CM motion,
Whoa.
what is it, activity?
You need the brackets first.
Maybe that's what it is. CM motion activity man. Oh yeah, I did need the brackets. Is activity available? And if it is, it's the danger of using autofill, and it didn't even do it. It didn't even do it. CM manager equals.
Underscore.
Wow, that took longer than necessary. If you guys haven't noticed, I can't type very well. Okay, so what's going on here? Okay, so now I'm going to call self.cm manager start activity updates to queue. I told you it was okay to use the main queue on this. Okay, so we're going to go ahead and get to the queue, main queue, between, got some code here that it wants me to handle, and da-da-da. Let's take this, we'll just move over a bit. Okay, so let's display whether or not I am running. Okay, so I'm going to display whether or not I'm running. I'm just going to copy and paste this little steps label, right? That should be fine. Let's do that. Yeah, it's good to go. There's nothing that's going to happen that's wrong with this, right? Absolutely nothing. Right? So I'll just come over here. We'll go to the butler, right? Let's create an outlet for this label right here. So I'm going to control, drag. There's an outlet right here for my label. And I'm going to call this what? My activity label?
Label running.
Label
Is running.
is running. Except the L and the I look very similar. Okay, so I've got label is running. Is there anything wrong here?
You should delete the default text or write something else. Because when you open the app, you just see steps there, and then it will just change to running.
Right. Okay, so we'll do that. Let's go in here and fix this because it's bugging me. All right. So I think we're good. So the second that I gave a new outlet to this, it was fine. When I copied and pasted it, it also copy and pasted the outlet that this had. So it was also going to have the same outlet as the label, right? Label steps counting.
How come you didn't have to delete the other one, or is it like a?
It's because it's essentially because I assigned it a new outlet, and it knows that it only gets one outlet per view controller.
Really?
Right? That makes sense for serialization. Yeah. Okay. All right. So now we're running on the main queue, so I can go ahead and do all the user interface stuff that I want to do. So self.label is running. .text is equal to ns string with format. Running. Now what?
Don't you need like an if statement?
I can do a %d here. I can do 0 or 1. It's probably better if I do yes and no.
Oh, okay.
But for the demo purposes, I'm just going to throw it in there. Right? And so I've got this activity. So I'm going to say activity dot running. And it's a Boolean. Or bool. Type def Boolean. All right? Is that going to work? I believe it's going to work.
I wonder what is considered running. What's speed?
Hey, I'm running. Look at that. Oh, I don't know. You gotta keep going. It's like maybe it thinks that I'm in a car now. It's like,
Maybe you just need like bigger motions.
Yeah, it's probably because of the like a jump.
Yeah, you need larger like
maybe.
strides.
Does anybody want to run around? No? Everyone's like, no, we're good. But it's also keeping track of the number of steps and things that are there. Okay? So running equals 0. I probably should have done that to stationary, and then I could have moved it, and it would have done it. Anyway, it's there. Okay? The automotive function on here, where basically is the person in the car, works remarkably well. Way better than I thought it was going to. All right? It works really, really well. And it does not access the GPS for that information. It's super low power. It knows if you're in the car based on the acceleration and everything else that's there. Okay?
It kind of makes sense because when you're in a car, you're not like, bumping. You're just like stationary, but
Yeah, but like,
camera is getting pushed
go
by.
ahead and expose it in the application, and you'll be in your car. You'll come to a stoplight. It'll still say you're in the car the entire time. The second you get out of your car, it's like, oh, I'm not in the car anymore.
That's gotta be like, I don't know.
It's the
I think it may have something to do with I'm looking at my phone trying to figure out if I'm in the car or not, and so it's like, oh, user interaction, and you're kind of you're probably stationary, and so it goes ahead and gives you the not is in car. I guess you could be in your car and still like texting or something. Don't do that. Okay. That is the M7 step demo. Are there questions on this? How do I make another queue? I'm going to get into that in the next demo, so we'll do that. Okay? There's like 3 demos in this class period. We're only going to get to maybe one of them. We'll see if we get to the rest, okay? Okay. Here we go. Okay, so when you want raw motion activity from the phone, there's a myriad of sensors that are on there that you have access to and that you can use. The one that everyone knows about is the accelerometer, but you also have access to a magnetometer, a compass, and a gyroscope, right? Which tells you turning velocity, essentially. Okay? The M7 mediates your access to all of that data, right? So the CPU is never querying the accelerometer, not anymore. That does not happen. It's querying the M7 with regular intervals when you want that raw data. Okay? That means that it's much, much lower battery consumption. So essentially on the 5S, let's say if you were sampling if you wanted to get, like, say, the accelerometer or the accelerometer and the gyroscope, if you were running that at 20 hertz, which means you were getting a sample from the accelerometer 20 times per second, the phone itself was consuming anywhere between, say, 46 to 50% of the CPU to get that data. Okay? And your application, just to handle that data, the queries that were coming back from it, right? Because there's some pre-processing that the phone was doing, right? It was making sure you had good accelerometer data. You to query, it was going to take up about 5% of your application. At 100 hertz, it's still about 50 and 51%, at 15 and 10% running in your application. With the M7 coprocessor, this percentage goes away because the CPU, all it does is it's doing a query to the M7, right? It just gets some bits on a bus. Does Does anybody know what the battery life of the 5S now is when you're doing, let's say, 100 hertz or 20 hertz? 4%, 1%. It's probably closer to 0, but I rounded up. Okay? It's extremely, extremely efficient. You can run this all day on a single charge from the phone. Okay? Which is cool. That's great. That means that you as a designer don't have to worry about that stuff. When you start messing with the GPS, that's when you need to worry about power. Okay? And if we have time, I want to talk about it in this class. Okay. So what I'm going to do now is I'm going to talk about accelerometers so that we can, and I'm going to talk about how they work just a little bit, the bird's eye view, so that you know where the pitfalls come with using an accelerometer or a gyroscope or a magnetometer. So how does it work? It's a solid state device. What does that mean? Well, that essentially means that it's a chip. Okay? It's built on silicon, right? And essentially what it is it's a device that if you were to look at a microscope of what this accelerometer looks like, it essentially looks like this. It's got this slick around it, which is silicon, and then in the middle of it, it's got a mass, right, which is another piece of silicon. It's extremely, extremely small. But there are connections between here and here, so it knows which direction that mass is moving in, right? And a mass only moves when you apply force to it, right? So it'll go right, go left, forwards, backwards. It can go up, it can go down. And so it's going to figure out acceleration in any of these axes, right? So in the X direction, the Y direction, or the Z direction, okay, when you're moving the accelerometer. Because of that, it does have specs. These are my best guess at what those specs for the accelerometer are because they are not publicly released by Apple. But essentially, it can detect force that's between plus or minus 8 Gs. What's up?
Did you go plus or minus 8 Gs to get this?
No, I got this from the internet. All right? I did not go 8 Gs. Like, I would have to be in a plane, right? And be like, what's it doing?
It
Yeah.
sounds like it would be a really cool story.
It would be a really cool story. I'm not that cool. So, bias and variance. So bias happens when essentially you're getting an accelerometer data where it's telling you that the acceleration is more than it actually is or less than it really is. So some kind of bias on the sensor. That essentially happens when this mass gets maybe a little out of whack or something. It wasn't manufactured properly. And like there's always a constant, 2G down that the chip thinks is there that isn't accounted for. You're not going to see that. It's a pretty high quality accelerometer on the iPhone. You don't really see that. The bias can go up and down a little bit, but you don't see a whole lot of variance in the reading that you get back from it, right? So that mass is really, really sensitive. Sometimes it's too sensitive and it's wobbling around, and so you get a lot of variance in the acceleration estimates. The iPhone's pretty good about that, but it might have some slight manufacturing defects in it that give you essentially readings that are a little bit off, right? So you're not going to know the exact G-force that's applied, right? It might be a little more, a little less. The resolution is a lot higher than I thought it would be. It's about 20 bits, which is more than you're ever going to need. That means you can go down to 0.000015, 150, wait, 15 micro Gs. All right, that's really tiny. Okay? That's essentially a feather dropping onto your skin. Okay? It's really good. The bandwidth. Now this is important. Don't ever sample any of the device motion above 100 hertz. Because that's all it's essentially, it's got a low pass filter on it to make things more stable so you don't get a whole lot of variance. So it's essentially averaging some of the values that you get back. And you can only run it at 100 hertz. If you can run it above 100 hertz, you're just going to get repeat values. Okay? It's not changing fast enough to be worth sampling greater than 100 hertz. If I'm sampling at 100 hertz on the accelerometer, what's the max frequency that I can get out of the accelerometer moving around? 50 hertz. That's pretty good. 50 hertz accelerometer, that's pretty good. You got to really, really like shaking it to get that frequency. Okay? 50 times a second you'd have to be on it. You can put it on a machine that kind of like a painting bucket or something to shake it. Don't do that with your phone, or these phones. You can do it with your phone, not my phone. Okay, so it's a little bit of a lie that an accelerometer is measuring acceleration. It's measuring something called proper acceleration, which is a force in a direction, right? Acceleration is usually defined as the derivative of velocity, right? You guys remember that from way back when in a math class, right? So acceleration was the derivative of velocity. Here, what it's really measuring is force. Now, force is absolutely related to acceleration, but it's mass times acceleration. Okay? That doesn't really mean much, except that it's a g-force that you're getting out of it. Okay? It's not the integral of the velocity of which the phone is moving. Are we out of time? What am I doing? 20 minutes. Okay, good. Sorry, I thought I saw people packing up. Okay. So, acceleration. If that is the phone right here, excuse me for the iPhone 5, it's not a 5S. If I'm going in the x direction, that means I'm accelerating the phone that direction, which is positive. Okay, in the negative x direction, it's that way. Now, what does that mean? What is acceleration, though? Like, when I take the phone and I move it from here to here, if I'm speeding up, that's a positive acceleration. The second I start to slow it down, it's decelerating. So that's a negative acceleration. So even though the phone is moving in this direction, if I'm slowing down, it'll be negative. Okay? And same thing with this, right? So I'll get negative, positive as I'm slowing down, right? I'll get positive, negative as I'm slowing down. All right? The y direction is this way, right? So I move the phone up that way. The z direction coming out of the slides is that way, okay? And that's the accelerometer. Accessing the accelerometer. Usually you don't want the raw accelerometer value. Why is that? Because gravity is pulling down on that mass inside of the accelerometer at 9.81 Gs, right? Does everybody remember that this is the force due to gravity is 9.81? That's what it is. That's constantly pulling down on the accelerometer, right? Towards the Earth. Or the moon, if you're up on the moon. So, what's really nice about this is that the core motion API will subtract gravity for you from the accelerometer reading. All right? So, what there's going to be this class that you get access to, which is CM device motion, and you're going to call device motion. Okay? So, you can, absolutely, if you want to, you can get access to the raw accelerometer values. But you won't need to. Because this class mediates that for you. And if you go into device motion, you can get device motion.gravity and get the acceleration in the x, y, and z planes that it's due to gravity. Or you can go user acceleration, which is the acceleration in the x, y, and z planes due to the user. All right?
So the second one has already gravity subtracted from it?
So, yeah, so the user acceleration, so if I'm holding the phone right here, let's say I'm holding it, to where the z direction, I'll get basically like a constant force down out of gravity, but my user acceleration will be 0 in all directions. And if I start moving towards gravity, it still keeps gravity in that direction, and it tells me the user acceleration or deceleration is in that direction. Okay? So, again, everything has an x, y, and z coordinate. Right? So the acceleration due to gravity when the phone is like this would be y equal to negative 9.81, but you wouldn't see any of that in the user acceleration, right? And for all of these different orientations. When I hold the phone in the z direction, you can see it there too. Okay, I will come back to that, the accelerometer, but we're going to do everything all at once when we do the demo. So here's the gyroscope. Has anybody ever seen an old style gyroscope? It's like a ball like this, and it's like, yeah, it could have water in it. Some of them have masses in it where they're spinning, right? And essentially, when you try to move something that's been spinning, you try and move it in one direction. There's a force that tries to keep it in the axis of its rotation, right? So if you've ever seen that, like a physics thing, if you're ever in a physics class and you see someone holding a bike wheel, right? They'll hold a bike wheel and then hold it by the spokes. It's really difficult to turn it in basically opposite of the axis of rotation. A gyroscope uses that resistance to tell you whether or not I'm accelerating in a rotation direction, right? Because the accelerometer is not telling you that. The accelerometer, if I move this way, it's not actually telling me the rotation, right? It's not telling me a velocity. The gyroscope is going to tell me a velocity that I'm turning the phone around with. So why is there a tuning fork? Right? Because there's not something spinning inside of your microphone. There is a MEMS device. Anybody know what a MEMS device is? It's essentially micrometals. Okay, they're really, really microscopic. This one inside there is vibrating. Right? So it's vibrating very, very quickly. It's something that you can do just by applying a voltage. And essentially it works like a tuning fork. When you take a tuning fork, it's the same way as if you were trying to spin this. You take a tuning fork, you hit it really hard and then try and move it. There's a force against the rotation direction you're trying to move it in. Okay? And essentially, you can use that to know the rotation of the device. Right? So what that tells you, it doesn't tell you the actual like which way the device is. It tells you when you're moving the device in a rotation. Okay? So, how many people know about the right-hand rule? Yes! Excellent. We're going to have to use the right-hand rule. Why? Because the gyroscope is telling us which direction something is turning in. So, I'm still going to have my x direction like this way. If I'm accelerating the phone positive, then I'm going to use my right-hand rule. I'm going to stick my thumb out, and then I'm going to curl my hands in the direction, right? So that is positive x, okay? If I'm going the other way, that's negative x, right? So positive, negative. All right? Is that okay? From the diagram, see what's there? Don't use your left hand, right? I have the best story about the right-hand rule that I'm not going to tell on video, but I will tell during lab. All right, so here's the y direction. Essentially, it's pointing up straight out of the phone, and again, the right-hand rule comes out of here. Z direction, it's the exact same x, y, z as you got from the accelerometer. It's just the right-hand rules in that direction, okay? So we're going to use this device motion variable again. Again, you can get access to the raw gyroscope data. But essentially, we also get access to it if we're accessing device motion, that class. It's going to give us back what the rotation rates are. So I'm going to have this variable here called CM rotation rate, which is inside device motion. So device motion.rotation rate is of this class. And again, I can get access to the x, y, and z values as I've defined over here to get the rotation of the device, the velocity, essentially, of the device. Angular velocity, right? Is that okay? I just said angular velocity. I think it's the first time I've said it. Okay, good. Okay, let's talk about magnetometers. These are one of the newer things that got put into phones in general, the iPhone here. What it does is it measures the magnetic field. And the magnetic field is measured in Tesla. Okay? So essentially the way that magnets are measured is there's a very tight coupling between electricity and magnets. So if you can measure an electric field, you can switch a few things around and you can measure a magnetic field. Okay? And everything that we have built today measures electric field. Okay? Devices do that. Devices do that even when you don't want them to do that. They're measuring electric field. This is something that's fairly easy to sense. Well, nowadays anyway, it's easy to sense, okay? I don't want to go into that. The Earth's magnetic field varies from location to location, but essentially it's somewhere around 50 microtesla. So the iPhone, the magnetometer on it can measure up to 1 Tesla, which is a lot. It's a pretty big magnet, okay? With a resolution of 8 microtesla. What that means is that the iPhone is sensitive to the magnetic field of the Earth. Why is that important?
You want to know where you're pointing?
Yeah, because you can measure the magnetic field of the Earth and use it as a compass. All right, the magnetic field of the Earth, if you look at a map of it, it's a little odd, but essentially it's pointing north and into the Earth. All right, it's not straight down, but essentially north and inward into the Earth. Okay. magnetic fields have direction. All right? So does everybody remember this from like high school or maybe elementary school, actually? You put magnets together, you drop a bunch of things down, and you can see the magnetic field around the magnet, right? So there's a north pole and a south pole. These lines exiting the north pole, and they enter back through into the south pole. So there's a direction to the magnetic field, all right? But it's not as simple as this. A magnet is three-dimensional, right? It comes out of the north pole, and then, out of the north pole, and then back into the south pole. Right there, and it's going around the magnet in 3 dimensions. So if I had a really strong magnet here in my phone, it's going to tell me which direction the magnetic field is and how strong the magnetic field is. So if you want to measure the magnetic field along an axis, it is towards the south pole of the magnet, right? This inevitably becomes confusing. The south pole of the magnet, if you're measuring Earth's magnetic field, the south magnetic pole is at the north pole of Earth. Okay? And that switches every once in a while. Every, I don't know, every 5,000 years or something. Probably not going to happen while you're taking this class.
The sun magnetic field changed like recently, I think.
It might have. If the magnetic field changes, it could blow all of the electronics on Earth. Right, and then we would have to basically, I don't know what would happen. It'd be like Walking Dead around here. Yeah. So essentially, so if the phone is right here, this is how you would measure, right? If I put this next to a magnet, this right here, what would the readout be? Does anybody know? So if this is the phone orientation and the magnet's right next to it, which of my X, Y, and Z values would actually have value in it?
Why?
The Y. In the negative Y direction, right? Because this is along the magnetic field for that. If I were to put it this way, I would have magnetic field in the positive X direction. If I were to put it this way, it would be in the positive Y direction, right? Pretty cool.
How powerful and how fast does the magnet have to be to actually impact that?
Not very powerful. I mean, it's picking up the Earth's magnetic field. You can take any magnet that will stick onto metal, you can stick next to the iPhone and do stuff with. I've seen people at different conferences that will have tangible interfaces with magnetics. Like they'll have magnets that do certain things around the iPhone to enable interaction and like play games around the iPhone with it. It's pretty cool. And you could do that with this class's final project, absolutely. Question?
So we're going to screw up the compass whenever we want with another magnet?
You can absolutely screw up the compass whenever you want with another magnet. Not only that, the magnetometer on any phone has drift in it, which means the sensor gets more and more and more and more off as it's on. That's why you have to do this little thing, this thing. You're recalibrating it as you move it across the magnetic field of the Earth. And it's like, oh, okay, I got it. Yeah, there. I just honed in on it. Good. I'm better now.
Does anything bad happen to the phone if you put like a magnet, like touching it or like super close to it?
Super close to it.
Yeah.
Why would that be a bad thing?
Because you can flip the bits and change the
You can flip the bits. In what?
flash.
In a hard disk.
Oh, no.
In a hard disk, you can do that. With flash memory,
It doesn't. Oh, okay.
no. Good.
You can just put magnets right there.
You can put the magnets right on it. I think.
Yeah, I don't want to wipe.
I don't think I'm trying to think about it. It's like, have I done that? And is there something that I'm missing that would allow you to do it? But I'm pretty sure you can just set it right on it.
Maybe it'll screw up one of the sensors.
It might screw up one of the sensors.
But not,
And you will probably throw off the magnetometer really, really quickly with a strong magnetic field. The bias will, you'll start, like as you move it away, you'll have to recalibrate to find Earth again. Okay? Okay, but your iPhone has electronics on it too. Okay, that means that the phone uses electricity and is therefore a magnet because there's electricity running inside the phone. Anytime you run electricity along a wire, it becomes a magnet. The iOS will subtract that magnetic field for you. So essentially, we're going to use this device motion class again. And it's going to be device motion.magnetic field, which is of type CM calibrated magnetic field. and it has 4 fields. The X, Y, and Z, magnetic field dot field has the field strength in the X, Y, and Z directions. And it also has the accuracy, which is either it's uncalibrated. You will get that on a device that does not have a magnetometer. How are we on time?
5 minutes.
5 minutes. Awesome. Accuracy low, medium, and high. And it essentially just tells you how out of whack it thinks the magnetometer is. And it's pretty good. Question?
I'll ask you afterwards.
Okay. Okay, so what does that mean? There's this thing called attitude, okay? Which is essentially, have you guys heard of roll, pitch, and yaw? No? Essentially, if you are flying an airplane, right, for those of you who hadn't, roll, pitch, and yaw tell you if you're flying in an airplane, you could fly like this, you could be turning this direction and that direction. Roll, pitch, and yaw tell you, relative to a static X, Y, and Z axis, where are you oriented? What's your vector direction? Okay, so what that means is that these X, Y, and Z factors, this is relative to the phone. It's going to tell you how the device is oriented, right? And this is something that wasn't available really until recently. Essentially what's happening here is the M7 processor in real time is going in and it's taking magnetometer readings used as a compass. It's taking gyroscope readings to detect quick rotations of the device. It is integrating accelerometer readings to tell how fast you're moving, and it is actively giving you an estimate of the roll, pitch, and yaw of the phone in real time, and you get it for free.
Which roll, pitch, and yaw?
So which is roll, pitch, and yaw? Good question. I have a slide. Okay, so yaw is in the XY plane of the phone. So as you move the phone this way and that's yaw. Okay, and it's going to give you something between 0 and 360 degrees, right, for the yaw that the phone is in. Pitch is in the YZ plane, right? So like I've drawn it here. So it's like this. All right? That's the pitch of the phone, right? So it's going to be 0 degrees, 90 degrees, 180, 270, back to 0. Okay? Which is pretty cool. Yeah, I know, like, you guys are like, oh yeah, this is really neat. This was so long in the making. Anyway, the roll is in the XZ direction, so when you flip the phone around, essentially like this. Okay? Really, really cool. All right. So essentially, what you want to do here is, and we won't have time to go into the demo, so we'll do it next time on Monday. But essentially what you're going to do here is you're going to call this class called CM Motion Manager. Very, very similar to your step and activity manager. And I called it M Manager here. The first thing we're going to do is declare it and then alloc init it. Notice I have not yet asked if is device motion available. I have allocated and initted my manager, and then I can call this is device motion available. I have no idea why Core Motion does it this way. You should not be calling is device motion available on the instance of the class. That should be a class method. Apple, please fix this. I don't know what's going on here. But essentially, we're going to check and see if the device is capable after we've instantiated. If it's not, I want to set that back. I want to set this equal to nil. I don't want to be using it. All right? But if it is available, I'm going to call this thing called set device motion update interval, your sampling interval in seconds. So if I'm sampling at 100 hertz, what would I want to set my device motion update interval to be?
1 over 100.
1 over 100. Perfect. 100 samples per second, so 1 divided by 100. That's the length of time between each sample. That's as fast as I want to go for device motion. And then I'm going to call this thing called start device motion updates to queue. I'm going to give it the main queue right here. And then I'm going to say with handler, CM device motion, and then I'm also going to get an error. So inside of this handler is where I get access to the data. Okay? All right, so I have this device motion.attitude, which is roll, pitch, and yaw in degrees. I have rotation rate. I have the acceleration due to gravity in the x, y, and z directions. And I also have user acceleration and magnetic field, calibrated. Very cool. What is wrong with this code? What is wrong with this code? Main queue is probably not a good idea. I'm probably going to count you off a lot if you're running this on the main queue. Why? Because it's getting 100 updates per second. I don't want that running on the user interaction. However, if I want to use the device motion to update my UI in some way, I need to call perform selector on main thread. Okay? Only when I need to do UI updates. So essentially, we'll do the device motion demo next time. Am I out of time? 2 minutes maybe?
-1 minute.
-1 minute? You guys can cut me off. You say, hey, it's time. I'll be like, okay. All right, let's go back to the audio lab and figure out what's going on there, because it's due Friday, and I will be here. Tomorrow and Friday, I will be around all day and most of the evening and night. Okay? So I will be available. I will probably be here on campus. The reason for that is my kids are going out of town, so I'm here. Okay? All right.